So I wanted to sort of start this talk by showing, one of these really sad, tragic pictures of what plastic pollution looks like for many of our colleagues and friends around the world. So plastic is washing ashore in large numbers. And if you look at a lot of this plastic is, coming from other places around the world, whether it be coming from point source places like rivers or dumping into the ocean, which often happens, or it can also be coming from things like marine fisheries activities. But if you look at Our World in Data, which is an excellent resource that I recommend to anyone who's curious about this issue and sort of wants to learn more about, the presence of plastic in our world and in our oceans. In many ways, this process makes a lot of sense because since 1950, we've seen a huge increase in the global annual production of polymers and fibers made from plastic, right? And so here you can see this graph, and on the x-axis on the bottom, you can see years starting at 1950, which is when plastic really entered sort of the global markets in a real way, up to 2019. And on the y-axis, you can see the hundreds of millions of tons that are being produced. And it's this nice sloping line where we have, essentially an increase in plastic over time. And as an ecologist and as an environmentalist, one thing that is quite common in nature is to have a large increase in the production of something. And oftentimes, even in the natural world, the response from the environment will lag. And so the human response to the plastics we have created in our own environment has also lagged quite a bit. And because we have a lag between the production of plastic and what we ultimately do with the plastic that's no longer useful for us, we have this major crisis today. So here's a map showing the plastic pollution that's entering the ocean through rivers in 2019. And you can see the scale on the bottom with the sort of light orange shows, the tonnage of plastic entering the ocean. And with the dark orange, we're seeing, a million tons or more of plastic entering the ocean from these parts of the world today, with the gray shading as no data. And I wanted to share this because I feel and believe it's very important to make clear right from the onset that this is very much a global problem, that there's no single point source, city or community of people that we can sort of point out as being like, aha, you're the ones, right? There are, some places that may have a little bit more plastic entering the ocean, some places a little bit less. But oftentimes, that plastic entering the oceans and the volume of plastic entering the oceans isn't just about the amount of plastic waste, but it's also about things like the size of the rivers that are entering into the ocean. So you can see, for example, places with very large rivers like Ganges or Amazon, may have more plastic entering the ocean. But importantly, about 98% of plastic entering the ocean ends up on shore. So the plastic that we put into the ocean from land sources and river sources, most of that, the vast majority of that, ultimately washes back to our shores within about 1 to 2 years of entry into the ocean. And we get pictures like this, where you can see, terrestrial plastic, that's what we call plastic that enters on shore, coming back to shore. But also there are regions of the ocean where we know that plastic is concentrated at a higher abundance. And these regions are often called garbage patches. And this is because if you look at sort of a mathematical representation of plastic entering the ocean, as plastic is swirling around, it sort of gets caught up in these areas where there's not a lot of current movement. And so these are relatively calm, almost meadow-like areas of the ocean where the waves are particularly flat, and the sea is just very quiet. So we have these very quiet regions of the ocean where floating objects can collect. And one important point that I always like to make when I start conversations about these so-called garbage patches is that people often assume that the plastic in the ocean and in all parts of the ocean is all the same. But in the case of the garbage patches, most of the plastic, about 75%, is coming from fisheries and fishing gear. So now we have a new player in the game of thinking about plastic pollution in the ocean, not just what are you doing as a consumer with your plastics, and are you being responsible steward of the environment when you um, decide whether or not to buy plastic products, but also what kinds of fish are you buying, and where are those fish coming from? That actually the question of the kinds of fish you are consuming also has important implications for plastic pollution in the ocean, which is something I don't think many people think about. But I will confess, I really didn't come to this area of research because I was interested in plastic. I came to this area of research because I was interested in these strange animals. And so I wanted to take a few minutes to share with you an ecosystem that very few people have heard of, that really I only started studying about 5 or 6 years ago, precisely because. I was thinking about the impacts of plastic and plastic cleanup on marine life. So I'd like you to meet a group of animals that we scientists collectively call sort of the Neuston. And the Neuston are any animal that floats, or really any organism that floats at the surface of the ocean through its own means. So these are not organisms that are riding on floating objects like plastic or driftwood, right? These are animals that are living at the ocean and floating because that's how they evolved, right? That's how they live their life. And so, one example of a floating animal that I started studying was this by the wind sailor, Valella. And this is a kind of jelly. So you can sort of think about it as similar to like a jellyfish. It's a kind of jelly, but instead of sort of pulsing in the water, it has this raft that it makes. It actually makes this raft out of a sort of a secreted molecule very similar to our fingernails. So in the with a similar texture of fingernails, it sort of builds this little lifeboat for itself and even includes a little sail on the surface, which you can see right here, right at the top. So that little triangle, that clear triangle, is actually a sail that sticks out of the water. And these guys use that sail to sort of float around. And then they have this sort of living constellation below them of a mouth and a bunch of tentacles that it sort of uses to eat. And these animals can occur in phenomenal, vast numbers. So here's a photograph taken of some of these by the wind sailors off the coast of Washington State here in the United States. And every little sort of sand grain looking blue dot is one of these little jellies, which can be about as large as the palm of your hand. And they can stretch for tens of miles in these large concentrations that form at the ocean surface and are eating sort of small crustaceans in the water and are in turn being eaten by things like fish and seabirds and sea turtles. So they're very, very popular dietary component for things like loggerhead sea turtles and Lysander albatross, which is important and we'll get to later. Um, but there are also animals like these beautiful blue button jellies, porpita. These also float on the ocean surface in a little sort of life raft of their own making with sort of a fingernail textured little raft you can see in the middle that's shaped like a coin. And then they have these tentacles that sort of pulse in and out. And they pulse in and out, right? And these can occur also in very large numbers, and we see them washing up in places like sort of central West Africa, near Goa in India. We also see them washing up in the Gulf of, the United States, from Texas to Louisiana and over to Florida. So these are also very common on the ocean surface. And then finally, one of my favorite animals on the ocean surface is this incredible sea slug that's sometimes called a blue angel or a blue sea dragon or a sea swallow. And these slugs swallow air to stay at the ocean surface and then float right at the ocean surface and use those kind of big hands to actually catch potential food and other prey items that they then consume. Um, and I wanted to share all of these animals with you because even though they're quite remarkable and they're quite beautiful, these are animals that very rarely wash ashore, right? And so most of these animals will remain mysterious to us for their whole lives. In fact, I've been studying marine biology for 20 years, and I only just saw some of these animals about 5 years ago. But these animals float like plastic on the ocean's surface. So you'll remember these models showing plastic pollution and where it might concentrate. Well, as a biologist, I had a question about where are these animals on the ocean surface? They're so rare, we don't see them, but certainly the ocean is huge and they must be somewhere. So, in collaboration with a colleague of mine, Nikolai Maximenko, we first set out to answer this question by using mathematical and computational simulations to essentially recreate the complex surface of the ocean in a computer, including the wind patterns on the surface of the ocean and the sea currents at the surface of the ocean, to try to see if we could predict where these animals might be. And we're rather surprised to find that for animals like that blue sea dragon or the blue buttons porpita porpita, or even these strange little snails, that they are predicted to concentrate in a region of the ocean that we call the garbage patch. And even for the animals that have a sail, like the Valella I showed you, or perhaps you've met the Portuguese man o' war somewhere in your own time, these animals also seem to concentrate, at least in our computer simulations, in this region of the ocean. And so we really had this kind of burning question, do these animals co-occur with our plastics in the open ocean? And to answer this question, we ended up partnering with a very unlikely friend and colleague. Ben Lecomte is a swimmer who has made it his mission to swim across various oceans. And when we first met Ben, he had just finished swimming from Japan to Hawaii and was getting ready to finish his swim across the Pacific by swimming from Hawaii to California. And you can see his sailboat in the background that's crewed with people whose job is to make sure, Ben doesn't sort of drift into the ocean. They follow him, they make sure that he has food and water and a place to sleep at night. And every day he gets in the water, they drop a GPS coordinate for sort of where he started. He swims for 7 to 8 hours a day. And then when it's time to rest for the day, he gets out, they drop another GPS coordinate, and the next day they go back to that exact same spot and drop Ben back in the water. So he is really someone who's had his eyes and ears in the ocean more so than any marine biologist I know. And he offered to help our research by taking samples for us as he swam. And so Ben himself didn't take the samples, but his crew would drop a net into the water at various places between Hawaii and California to see if we could ask the question, are there really more of these neustonic animals in this region of the ocean that we've been referring to as a garbage patch? And so here's Ben's sort of path, his swim from Hawaii to California. Here's the actual journey that he took. In orange, you can see the predicted distribution of the area we call the garbage patch. Now, the garbage patch is not actually a patch of garbage, so you can't actually see it from space. In fact, this has been swimming through that region, and you can see it looks just like any other ocean. It's quite empty. But in the same way that we saw those microplastics concentrating on the shore in that lovely picture from earlier, we see plastics like that in this region of the ocean. So we can't actually see it from space, but we can use our same mathematical models with currents to predict where it might be. And that's what you see in orange right here. And when they dropped the net in the water, they were able to drop it outside of the garbage patch in these sort of blue squares and inside the garbage patch in that orange square right in the middle. And this is what we found inside the garbage patch with this collaboration with Vortex Swim, which was Ben's sailboat. And what I want you to really see when you look at this picture is the contents of the net that have been dumped onto this sieve. And we have someone with their slightly banged up hand sort of picking objects out of this contents of this net. And you can see that there are plastics in here. So there's like some little orange fragments of plastic and some little yellow fragments of plastic. But you can also see just a vast amount of blue stuff and purple stuff. And if you sort of get close to your computer and squint in, you will see that all of that blue is life. That is all of the Neustonic animals that we've been hunting for and studying and wondering, my goodness, where could they possibly be in the world? And it turns out that they are here. When we look at the concentrations of plastic on the x-axis, so here on the bottom of the graph, and we look at the total numbers of Neuston per meter cubed on the y-axis, so on the vertical component of this graph, you can see there's a strong line showing a positive relationship between the amount of plastic and the amount of Neuston. And this really drove home to us that the same currents and the same wind patterns that are bringing plastics into these sort of far flung places are also driving these animals into those same places. And importantly, the Neustonic animals that are out there are not there because the plastic is there. They're actually there in spite of the fact that the plastic is there. In fact, we realized quite shockingly that we've been calling this area a garbage patch because we didn't know that there was an entire ecosystem that had been there long before our plastic ever showed up. And that this ecosystem at the ocean surface is the true resident of this region of the ocean, that it's not a garbage patch, it's a sea of life for things like blue sea dragons and blue button jellies and by the wind sailors, that this sea of Neustonic life has been in this region concentrated for much longer than the plastic, and the plastic is a pollutant of that ecosystem. And when we realized that, we started putting together this food web of, okay, well, what eats all of these animals that float at the surface? And discovered that, as I mentioned, many of the animals like loggerhead turtles and Lycaen albatross that prey on these floating animals are the exact same animals that we see eating large concentrations of plastic. So they're going to these regions where they know their favorite crunchy meal is, right? They're finding these animals that have a texture that's very plastic-like. Remember the sail of the by the wind sailor has kind of a fingernail consistently. See it actually, the first by the wind sailor I ever saw, it was a dead by the wind sailor on the beach, and I thought it was plastic and I tried to recycle it. They really feel like plastic. So these animals are going out, they're finding what they think is a yummy treat, and that treat turns out to be plastic instead of these blue organisms that they're looking for. And this is true, we realized, both out in the farthest reaches of the ocean, but also very true close to shore as well. So even right here close to shore off the coast of Hawaii, we see life co-occurring with plastics. So if we look, for example, at this picture, you'll see there are all these light colored lines. These are called wind slicks, and they cover about 8% of the surface. But within these slicks, we see 40% of baby fish. We see 26% of surface invertebrates and about 95% of plastic. And so the reason why I wanted to share this with you is that it's not just that life and plastic sort of exist in isolation in the ocean, they exist together. And our plastic is really polluting their ecosystems and habitats. And I was excited to join you today because this really has important implications for how we fix the problems that I feel like church leaders are uniquely positioned to address. There are many people that want to fix issues like the garbage patch by using things like this, these well-meaning manta boats that will go and hoover up plastic and life and sort of throw them away in dumpsters, or these big sort of eighth continents floating on the surface, right? Or even more, sort of immediate things like this company called the Ocean Cleanup that wants to use giant nets to scoop up plastic. But there's no way to remove plastic from the ocean without removing all the marine life that's intermixed with it, right? And so this kind of solution, this large technological solution, is actually, I think, a new problem that we're creating rather than a solution. And remember that 98% of plastics entering the ocean wind up on shore, that 75% of plastics in these so-called garbage patches actually come from fishing gear. It's not these big tech solutions that are most likely going to solve this problem. It's communities that are going and collecting the 98% of plastics that wind up on beaches. It's consumers changing their consumer habits related to fishing. It's policy changes and community changes that are really going to make a difference. So the best place to help is here. The best place to solve the plastic pollution crisis is actually on land.